Good morning, everyone! Brace yourselves because we are now here at the PanSET Museum, where we will meet different mathematicians around the world. But before we go inside, I want you to find a partner who you will be working with throughout this trip.
Hey, Michael, let's be partners. This is so exciting.
I agree. I can't wait to learn more about their works. Let's go!
Welcome to PanSET Museum, the home of classical and modern mathematicians. Now, I will give you the freedom to explore on your own, but you must name your math hero and explain to me why you have chosen him before we leave this place, okay?
Let's go this way.
Okay.
Hey, do you know him?
Nope. I haven't heard about Paul Bernays.
Yeah, me too. I only know Barney.
Oh yes, the purple dinosaur. Maki, look! I think this is Georg Cantor, the father of set theory.
Oh yes, I've also heard that he is a German mathematician that mainly focuses on the mathematics of the infinite and discovery of cardinal numbers.
Look! There's more! Set theory is said to be developed during the end of the 19th century and serves as a foundation of mathematics.
Wow, that's cool. Let's open this book. I want to know more. Where are we?
I think we are inside the book.
Hey, is that Mr. Georg Cantor?
Yes, that's him. He's in the picture at the museum.
Come, let's go.
Good morning, Mr. Cantor.
Hello, kids.
Are you really the father of set theory? How come?
Actually, there were also other mathematicians behind the discovery of set theory.
Really? Who are they? Are they your friends?
Can you please tell us about them, and I want to see them too. Do you have their pictures?
You're lucky I still have their photos. This was my colleague, Richard Dedekind. He was also a German mathematician, and we collaborated on the true definition of a set. May it a finite or an infinite, a set is a collection of objects that share a particular property while keeping its uniqueness.
Oh, so you and Mr. Dedekind established the true meaning of a set? Now I know.
Here's another one. These are Ernst Schröder and Felix Bernstein. They were also my fellow German mathematicians who helped me create the Cantor-Schröder-Bernstein theorem. It shows that if the two cardinalities are both less than or equal to each other, then they are equal.
Oh, I've never heard of that. That's cool.
Are you familiar with Cantor-Lebesgue theorem? I bet you're not. Cantor-Lebesgue theorem states that if the coefficients of a trigonometric series tend to 0 at each point of a set, if and only if the smallest additive group containing that set has a positive outer Lebesgue theorem.
So, I assume, Mr. Cantor, that the mathematician's name who you had collaborated with is Lebesgue?
Oh, I know him. He is Henri Léon Lebesgue, a French mathematician. Is that right, Mr. Cantor?
You are both bright kids, huh? Yes, he is Henri Léon Lebesgue. The last colleague of mine that I want to introduce to you is Ivar Otto Bendixson. He was a Swedish mathematician who helped me establish the Cantor-Bendixson theorem.
Cantor-Bendixson theorem?
Yes, that theorem states that every uncountable closed set can be partitioned into a perfect and a countable set.
Wow, Mr. Cantor. Aside from you have proposed lots of theorems in mathematics, it is nice to know that you have also teamed up with your fellow mathematicians.
That's true, Mr. Cantor. You are really great. You were so cool with your friends.
Oh, I wish to have those kinds of friends someday when I grow up.
Mister, may I ask for your own contributions to set theory?
First, the concept of one-to-one correspondence. It is most likely we have sets A and B, and then with pairing of each object in A with one and only one object in B. Here's an illustration. From the given numbers in set A, each number corresponds to only one number from set B. My second contribution, the continuum hypothesis. There is no set whose cardinality is strictly between that of the integers and the real numbers. Thus, the cardinality of real numbers is exactly Aleph 1 rather than at least Aleph 1. However, I haven't proved this yet. Moreover, I discovered transfinite numbers. It is presumed as a challenge to the uniqueness of the absolute infinity, like God. However, transfinite numbers were the indication of the size of a specific infinite collection of objects. Hence, even though they are all endless, infinite collections have varying sizes. Lastly, my diagonal argument. I found out that the set of real numbers is uncountable.
Wow!
You really did great, Mr. Cantor.
You have contributed so much to set theory, huh?
Yeah, to be honest, I was amazed the whole time.
I think it's time for you to go.
Oh, that's sad. I still want to know more.
Yes, me too. Can we stay a little bit?
You can always find me on books and other references, don't worry. But for now, you have to go back to your field trip.
Oh, okay, Mr. Cantor.
Okay, class, time is up. We've already spent too much time inside the museum, and as I have said earlier, I am now going to ask you about your math hero. Who wants to go first? Any volunteer?
Us! We chose Mr. Georg Cantor.
Okay, go on. Tell us about him.
Mr. Cantor is such an intelligent mathematician. He is the father of set theory, where his contributions brought us all here. His influence made a huge impact, not only within his field, but inspired many people, especially those who supported him as his works become notable up to this day.
But aren't all of his kind as intelligent as him? What makes him different that you ended up choosing him, considering there must be math heroes that are greater than him?
Freedom. Mr. Cantor, despite his struggles, all he thinks about is freedom. He must have suffered throughout his journey.
Yeah, like Borali and Forty, along with Gottlob Frege and Bertrand Russell, who were once against his idea.
But instead of abandoning his goals and ideas, he kept on thriving as he left everything behind, or anyone who restrained him.
And
And that's why he is our math hero.
Wow, I am impressed. You've known so many things today. I hope everyone learned as much as they do. Let us now go back to our bus and be ready for our next trip in Ocean Park.